Yeah, Brainiacs. Man, oh man. I am indeed happy to be here with you guys as well as the guy sitting beside me in a virtual OBS studio. Correction on the name. That would be Mr. David Weiss, like ice.
Very good.
Very good. All right. Dave, welcome to the Matrix Minds. Everybody, again, dude, I talked to you. We're gonna, dude. I got root beer in my hand. I got chilled out. we're just gonna have a conversation, just you, me, like it's like our friends. You stepped into something that I have never stepped into. I have interviewed. I'm serious. Hollow Earthers. I have interviewed Hollow Earthers, holographic simulation, simulation altogether.
Concave Earthers.
Yeah. Yep, that too. Yep.
So we say that hollow earthers and concave earthers are here to muddy the water for flat earthers. They would say the same, so we're just going to let that go. I'm going to present to you today how I see the world, and here's something that I think we both can agree on. I think that we are both willing to change our minds based on new information. Would you say that's a true statement? Not necessarily about this, just about anything.
About anything, absolutely.
Okay.
I like I told you off air, brother. I am a truth. I'm not kidding. I am a truth seeker validator. So any information that you present to me, I assure you, and everybody in this chat and everybody with me will tell you, I will do my due diligence on research on it. Seriously, I will. I'm a truth seeker. Okay. Hell, I think somebody posted something about an astronaut drowning in space. I'm like, I know they carry water bags, so I'm like, water bag? Because I don't know, Dave. I don't know. I could tell everybody. I don't know where the hell I'm at. I don't know where I'm at. I've never been on the outside of this wherever we're at. So if you can tell me where you think that we're at, by all means, the platform is yours. Share with me.
So there's a lot to that I was trying to pull up. The ISS training is done in the neutral buoyancy lab. It's a giant pool with a replica of the ISS in it, and they do their training in there. So maybe that's how he drowned. So just the basics. At the beginning, you said a planet, a disk. It's not either. You're mixing models, and as you made in your poster, which is right here, you have the flat Earth, which is the incorrect flat Earth. No flat Earther thinks we're a disk floating in space, mixed in with a heliocentric model. This is a mess. It's pretty. I'll give you that. It's very pretty. It's very, very well done, but it's a this is mind control right here. This is what they want you to believe.
Oh,
so
okay.
So
for the correction.
Yeah, no worries. This is what I normally show, which is the same graphic that you got, and that's it. So what is flat Earth? Well, the globe says that the Antarctica is at the bottom. They also say Antarctica is the highest land on Earth. You might not have known that. When in reality, Antarctica is the land that surrounds our world. What do I mean by that? Large bodies of water at rest lay flat, scientifically, provably, testably, measurably flat. Okay? And large bodies of water need a container. If you had 5 gallons of water, but you didn't have a container, the water's not staying. It's no bucket, no water, right? Mm-hmm. A pond or a lake, a bigger pond, is contained by the shoreline that surrounds it. The shoreline is just the land that's higher than the water. It's a container. Don't believe me? Plow out some of the edge of the pond and watch what happens. The water will go away. Well, the world pond needs a container. That container is Antarctica. Antarctica is the land that surrounds our world. It's the highest land there is. We live in the Antarctic basin. Large bodies of water at rest lay flat. All of the islands, continents, they're surrounded by water, but all of the water is surrounded by its container. Okay? Now that sounds reasonable. It makes sense. It's scientifically provable. Unlike this. In the heliocentric model, I mean, if we get into how it was created, nothing exploded, became everything. That's cool. And then the rocks turned into round spinning balls, and the gases congealed into bigger balls that had more gravity and could hold on to those rocky balls, left a vacuum in between, scientifically impossible. And we're spinning, orbiting, and rocketing through this galaxy that's so big that you can never notice the movement. That's a ridiculous story. Do you know how fast the Earth is spinning at the equator?
Tell me.
Wait, by the way, I didn't know any of these answers when I was first asked.
No, I understand. You've definitely got a spiel going. You've done this many times.
1,000 miles an hour. 1,000 friggin' miles an hour. And now people go, well, I'm in an airplane. I can, drink a cup of tea or whatever and walk to the bathroom. I say, well, if you're in an airplane, you want to compare it to just the spin of the Earth. You have to take off the outside of the airplane. You have to double the speed of the airplane, and you have to ask the pilot to nose down a mile every 2 minutes, okay, or even faster, okay, because you're going faster. And that would mimic the spin of the Earth. We're orbiting at 66,000 miles an hour, okay? Mm-hmm. That is, you can't even fathom that, and we're chasing it at 500,000 miles per hour. Let me put that into perspective for you, okay?
The rocket sled, right.
Well, but now I have it with sound for the first time ever.
Okay, awesome.
Okay? Can you hear that? Can you hear that?
No.
You don't hear that? Well, it's fucking loud on my ears. God damn it. Okay?
No, damn. Okay, well, I can imagine it, just like you can imagine me.
So it's literally at half speed. Look, watch. This is at half speed. At half speed. Watch.
Okay.
You can't even see it, okay? You have to believe that we're going over the wow, I can't believe it didn't work.
I'm sorry, bro.
It's all right.
And it's not me.
It's not you. No, it's 100% me. It's OBS and Zoom, both of them, okay?
Wait.
So you have to believe that we're orbiting in a curved motion, speeding up and slowing down 10 times faster than that, and we're chasing the sun at 100 times that speed, and we have lakes that look like this. Think about that logic, right? They tell us because of the spin of the Earth, we're spinning. Neil deGrasse Tyson says we're spinning, and the water bulges at the equator 14 miles high. 14 miles high. Airplanes fly at about 5 miles high. So if I'm flying from North America to South America, at some point, I got to climb an extra 10 miles just to skim over a hump of water. Okay? Mm-hmm. You and I both know that doesn't happen. So why are they saying that? Why are they saying it bulges? Well, if we were spinning, it would bulge. Okay? But nature doesn't lie. Men lie. Okay?
Right.
Men lie. Get a plate of water and try to drive in a car or walk across your room or do anything. Just go any motion. You can't. The water's going to slosh all over the place. We're going 10 times and 100 times faster. Those are just two of the motions. Curving, spinning, twirling, whirling, speeding up and slowing down. And we have this. Game over. Earth is flat. It doesn't move, but we can go farther. Okay?
Okay. Okay. Yeah. I'm definitely going to need you to present something more.
I am. This is just the beginning, all right?
All right.
So, one of the questions is, like if you look at Antarctica from space, it's all cartoons. There's no photos of Antarctica except some, little camps along the shoreline, but the whole inner Antarctica, totally 100% off limits, and there are no pictures of it. So does that prove the Earth is flat? No. But it does prove that they're hiding something.
May I say something?
Yeah, you're in. Yeah, you're in right now. I'm done.
Well, don't be done.
Okay. I got plenty. Don't worry.
All right, so you've heard about the Ghislaine Maxwell case, right? I'm going to throw you something completely different. Right?
What? Ghislaine? Right? I just took off my my T-shirt about that, but go ahead.
Okay. She owned a travel business, okay, and one of them was Arctic tours.
Oh yes.
Okay. So she used to sell
Arctic tours.
Exactly.
Well, Ghislaine Maxwell was involved with Arctic tours. That's fascinating. However, there's about 100 companies that you can book to go to Antarctica. And when you go, they'll take you to this little peninsula right here off of Santiago. This peninsula is bigger than some countries. They'll show you some ice and some penguins. They will not let you explore the outer space, okay? Outer space. And they'll kick you out, and it's expensive. 100 companies all run under one parent company, okay? So that means that there's one company masquerading as 100 shell companies, right?
Absolutely.
Absolutely. So what's up with that, okay?
Well, the same thing with what's up with our money currency. I mean, you really want to be? I mean, dude.
No. I'm telling you that they're hiding something in Antarctica. They're hiding the truth of what our world is. I mean, anybody that tries to go there is turned away. Are you aware of that? So
well, I do know that it is I think different territories have now said that it is off limits. It's like completely a no-fight zone. They say it's uninhabitable, but okay, again, we've had people and heard of people taking tours to Antarctica or seen them, and how there's even people that's posted pictures of their tour.
So look at this right here. This is bigger than California. This is like, a third of the United States, a quarter of the United States, whatever. It's huge. Okay. They can take you there. You can take pictures. You can see the penguins. You can see everything, but no one's allowed to explore out here. This pink line is so far away from Antarctica that you can't see it. It's too far away. It's 1,000 miles away, whatever the distance is. It's 60 degrees south. Nobody is allowed to go beyond that line with extra fuel and without permits, and you can't even get the permits. Some fishermen tried it, and some other people tried it, but here's I'll just show you real quick. These fishermen broke the line. As soon as they did, they were like, hey, let's see how far we can go. All of a sudden, on the horizon, bam, a destroyer. They sent a drone after them. They radioed them, said you must leave the area immediately, okay? And this happens all the way around, and they have naval bases on 7 or 8 different islands surrounding the whole Earth. Here's the simplest way to prove that the Earth is a ball, all right? So, simplest way, where is it? Antarctica. Oh, no, here we go.
Well, you do realize that there's like some heavy military shit going on in Antarctica, as well as, let's just say, that's not just limited to there, okay? There's massive things taking place on the north side of things as well, okay? It's not just Antarctica that's off limits.
Well, so again, we don't know what's going on there. We're not allowed to go there. We can speculate, but if you look at what was I going to show you? Now I lost my thought.
Sorry.
I lost my thought. It's all right. It's I was going to show you something. Now I forgot. Go ahead. Continue where you were going.
Well, okay. If you go back, if you did go back, okay, just leave it there for a second.
Mm-hmm.
Okay. I'm assuming you've got the global model, right?
Mm-hmm.
Global design, and you've got Antarctica there. You've got looks like South America, right? And then you've got okay. So my understanding is, if you go back to your flat model, okay.
Mm-hmm.
What is the distance? Okay, I'm serious, from this cape, right, that you're talking about,
mm-hmm.
to the closest point of.
I got a better one. I don't know the exact distance from here, but people have taken it, and I had some friends that went this past year, and that's not in question. What's in question is they tell us Antarctica is about 11,000 miles in circumference. Okay, I was went on Google Earth and I measured it out with a line, and it was just under 11,000 miles. All right, so 11,000 miles. Here's what you can do: we can get 2 airplanes. Fly them over to the base over here. You and I get on there. We get Neil deGrasse Tyson. We get Bill Nye, the lion guy with the bow tie. And we get a whole bunch of scientists and professors. And one plane flies around this way, stays just off the shore, about 1,000 feet in the air. And we watch. We can see how fast we're going, and we can see the shoreline. And we follow it all the way around. And the other plane goes this way. Well, 5,000 miles later, 5,500 miles later, both planes will meet over here. The problem is it can't be done. They won't let you do it. It would put this entire flat Earth thing to bed. And the last person that tried to do it was Captain Cook in his boat. And it took him 3.5 years. And he went over 60,000 miles. The equator is only 24,000 miles, which is a smaller circle on a flat Earth. It's the biggest circle on a globe Earth, but it took him, I think he did it 3 times, 3.5 years, went over 60,000 miles. That makes sense on a flat Earth. It makes no sense on a globe Earth. Interesting, right?
That's really, that's definitely interesting.
Interesting. You know what? I'll take an interesting all day long. All right?
That's interesting.
So let's talk about circumnavigation. Is that cool?
Yeah, as long as it comes with mathematical like miles and meters and things.
Well, this one's a little different. Billions of people have circumnavigated east and west. You can leave New York, you can go over to Europe, you can keep going, China, and you come right back to California and you're home. And you went east the whole time. Right. You could do it the other way. Billions of people have done it. No one's ever done it north-south. Nobody has ever gone south and come back north. Okay, so let's see how that works on a flat Earth. On a flat Earth, the way the Earth is set up, the magnet is the center. I got a magnet here, and that's the magnetic north. And here's my compass. Now, my compass needle always has to point towards the north. I'm trying to push my compass west, but I have to keep turning it to the right to keep that needle pointed north. I am dead reckoning west. Okay, now I'm going to dead reckon east. I'm just going to follow the compass, and I have to constantly correct to the north to maintain that heading. I'm correcting to the north. I'm correcting to the north. I'm correcting to the north. If I don't correct, this is what happens. So right here, I'm about to take off. I'm about to go west, so I'm going to line that stick up, and now I'm just going to push that along the stick. I'm no longer heading west. I'm heading south. Because look, the needle has to point back here, and south is every direction away from magnetic north. This does not prove that the Earth is a globe or flat, because it works on both.
It does not. Here's the thing. Where's your South Pole?
Well, there is no South Pole. There is no South Pole. That's what you have to understand. Okay?
There's no South Pole.
So hang on.
Okay.
Explorers that have gone to Antarctica, they all say their compasses don't work down there. If there was a South Pole, compasses would point to the south, but they don't. You're too far away from the north. Compasses don't work. The magnetic declinations down there are so bad. Some of them are 170 degrees, which means if it says north is this way, north is really that way. Okay? It's all to confuse. It's all run by NASA. But watch what happens. This north is towards the center here, so we're going to head south. South. Now on a globe, you should pop up over here. If I left Santiago, I should pop up over here in Australia. But no one's ever gone south. Now you can go north, and watch what happens. As soon as I pass north, the compass does a 180, and now I'm heading south. Every straight line is south. Every straight line is south. Get it? And now on a globe, it's the same thing. If you were a mile from the North Pole on a globe, right, and you point your compass at the North Pole, there was actual pole there, let's pretend, okay, and you tried to walk west, you have to keep turning, and 6.28 miles later, you're right back to where you started from, okay, because you just went an equidistant circle around the North Pole. That's the same on a flat Earth and on a globe Earth. However, on a globe, if you're on the equator, you can actually go straight and drive around the equator. And then if you're south of the equator, as you go west or east, you have to correct to the south. You have to correct to the south because you'd be going around the smaller circumference. Get a ball, get a little car on it, and you'll see how that works. However, we have testimony from ship's captains that operate in the South Sea. They said whether they're going east or west, they always have to correct to the north. Okay? Mm-hmm. That's pretty good testimony. So, what else you got? I got plenty, but I love answering that. Host usually has questions.
My curiosity, because I've got a show host. We've got a show in Australia called The Matrix Minds 5.0. It's known as Kill the System. So Richard Roller is in Australia, in Melbourne, Victoria, Australia. Mm-hmm. And what's funny is, and this is no joke, this is before you came along, before whatever. Right before you, I would always kid him and say, well, you know, it's heard that the people in Australia don't even exist, Richard.
No, that's a joke. That's a meme by the mainstream media. No flat earther believes that.
No, I know. But I also kid him and say, hey, Richard, go check which way your water is spinning in the commode.
Yeah.
I said, I'll bet it's spinning right. Our water spins what? it spins counterclockwise.
No, our water spins on whatever direction the water enters the basin. The whole thing with those guys at the equator that move the sink from the equator to to the north and to the south, and they dump water in. It's how they dump the water in. If they just have a little spin in one direction, it goes in that direction. I have toilets. I have sinks in my house that will spin in opposite directions. Okay, it has nothing to do with the spin of the earth. The Coriolis effect in that aspect is not real. Now, do storms tend to spin in the same direction, in opposite directions in the north and south? Yes. And we'll get into why that is in a little bit. But think about this. If you push your hand or a paddle through the water, you'll see counter-rotating vortices. So in between our two tropics, the sun and the moon go around. They're electromagnetic in nature, and this is an energetic system we're in. And you talk about the toroidal field. Well, this energetic wave is spinning storms. Sometimes a storm, if the sun and the moon are on the far side of the flat earth, as the storm crosses over the tropics, it'll spin in the wrong direction in the wrong hemisphere. That would be impossible if it was the spinning of the ball that was making the Coriolis.
Dave, do you guys think, out of curiosity, that there is some other rational reason why that compass, the magnetic polarity of the compass, does not go south? It always points north, right?
Well,
and like you said, hang on, you go to Antarctica, it doesn't work at all. Do you guys a rational reason why nothing works in Antarctica?
Well, my rational reason, and I'm not the expert on this. There's some other people. If you listen to the show, Globebusters, and Cammie over there, she is all over these magnetic fields. It's above what I can fully understand.
Right,
but
we both probably. Yeah, I mean, I'm not.
But there's other people that are figuring it out. We have weird poles and stuff, and if you look at the tides, there's little spots all over the earth, over the oceans that don't have any tide. Right? Why there's other tides to the left of it and to the right of it, okay? But there's no tide in this little spot. Really weird stuff. On a flat earth, you have a compass, you have your North Pole, compass balances, works perfectly. On a globe, you have to imagine that there's energy coming out and wrapping around the ball, and your compass is following those magnetic lines. That's never been proven, okay? There is no South Pole, and compasses work level on a flat earth perfectly. It's interesting. Yeah.
Yeah, that's pretty interesting. Definitely. Yeah. See, but again, like I'm trying to tell you, I am not number one. I am not a physicist. Number two,
thank God.
No, I'm not going to do that. Like I told you, I'm not going to come here and argue. I'm not going to bring you here just to argue with you.
We're having a conversation, you and I, and you said interesting. I like that. It's interesting. Dude. There you go. There you go.
We are allowed to have conversation.
Let me tell you something. We had one of the people that helps me get on shows contacted you and hey, and you're like a flat earther, and then you and I, we had a few back and forth, and it was a little intense, and you're like, are you sure you want to come on here? And so you started watching my stuff a little bit, and it. Yeah, it's interesting. But here's the thing: when I heard about this, I just banned people from my social media for being so stupid to even suggest that I watch a flat Earth video. Right? You're too stupid to listen to my podcast, and I would ban them. But then I was forced to look into it, and I had to do it all myself. But this was back in the day where you watch a video, and then YouTube would go, here, watch this video, here, watch this video, all awesome videos. Now, if you search anything in YouTube, and you write Flat Earth in there, you get the same hit pieces. You get Not Professor Dave. You get Psyop Man Dan. You get these, what I call anti-Flat Earthers, right? Mm-hmm. They're not even globe heads. They're anti-Flat Earth, really disgusting. I don't even want to call them human beings because they're not, right? But they're here to deceive humanity. So I'm here to point to some doors. I want you to see them. I want you to investigate them. I'm going to show you how to investigate them, and you're gonna start seeing some things. Do not walk away from this tonight going, "Holy crap, the Earth is flat." You have to,
right.
You have to really look into it.
Like I tell everybody, do your research.
Mm-hmm.
Don't believe what I say. Please research it, because what I believe is my belief. It is mine. Dave, your belief is your belief, and if you give me a just a tangible taste of a nugget, and I pick up on it, you know what I'm saying? I'm going to dig deeper.
Yes.
All
So
right?
I have I know that one of the big topics is sunsets, and I want to talk about sunsets for a few moments. You good with that?
Yeah, go ahead. Absolutely.
So here is some street lights, and we know from experience, because we've been out there and we've driven and walked down roads with street lights, that these street lights are all level, but they kind of look like they're going down, right? That's just perspective. But we know, our brains sort it out, they're level, but they look like they're going down. Well, here's the sun going away, and it looks like it's going down. Now, it looks like it's going behind a horizon here, but what I can test this is I call it the atmospheric deck of opacity. What is the atmospheric deck of opacity? If you look up on let's say you have little cumulus clouds, and they're all sitting there on that flat deck, right? And they're all spread out. You look up, you see the blue sky, cloud, 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 beautiful. But 20, 30 miles away, I look down Long Island Sound. By the time I get to New York City, which is about 25 miles away, the clouds are literally sitting on the water. They literally come together. So where the sky meets the land, that's your horizon. Now, I'm looking at those clouds far away, and they look like they're right at my eye level. But in reality, they're still 5,000 or 10,000 feet in the air. Okay? But I see them at my eye level. When I watch the sun go down, away, it's not going down, it goes beyond those clouds, and it gets eclipsed. Just like if if I had if you were sitting there and the fence is above your eye line, and I'm on one side of the fence and I walk away, my head sets behind that fence, right? But if you were far away from that fence, the top of that fence would look like it's at eye level. Everything, the tops of the mountains and the surface of the water, all rise and compress to your eye level. It's how our eyes work. So let's go to the sunsets for a moment. I'm going to do a quick, not that quick, but it's not that long, explanation. All right. So this is my flat Earth kitchen. This line, is this level? This is my counter here. It's kind of dark. It's a black counter. And the line is level, and I'm viewing it from a celestial point of view. So here's my sun, and I'm just showing you that the sun is traveling on a level line over the flat Earth counter. This could be mountains, a city skyline. It could be the cloud deck, but the sun is above it the whole time, right? It's above it, straight line. Now I got a camera on the counter, which is way below this, on the other side, watching this go away, and watch what you see. Right? From a terrestrial point of view, look at this line. Does it look like it's going down? You would say yes. And I'd say, this is at your eye level now, but it's really above it. It's just that it's farther away. And it looks like it's going below it. And if I showed you this first, you'd go, yeah, that's going down and it's going below it. Now watch, I'll zoom in even farther. Look at this line. It's more down than it is level. It's almost going straight down. As the sun goes away, it's going behind this horizon, which is well above the eye height, but it looks like it's at the eye height. Now here's a real sunset. Now you would expect the sun to go behind here, but right here is the atmospheric deck of opacity, and the sun is just going away, just like here. Let me show it one more time, right? It's just going away. This deck that it's going behind could be 10,000 feet in the air, but your eye sees it at eye level.
Correct.
That's how a sunset happens on a flat Earth. So now let's look at some real sunsets. So here's one in Bulgaria. Super clear day. And now, if you live on a spinning ball, you believe that the sun is stationary and you're falling over backwards faster than the speed of sound. Okay? That's what you have to believe if you live on a ball. The sun is clearly going away, and light is like sound. It only goes so far. Okay? It's taking its light with it. And as it goes away, and it goes into the atmospheric deck of opacities right here, even though it's a clear day, over a certain distance, it becomes opaque, and it takes its light with it. It's not below, it's just away.
So where do you think the sun goes? Let me ask you.
Great question.
Where do you think that it goes when it vanishes from east, or as it reappears on the east? It vanishes on the west to where? Where do you think it goes?
So here's the flat Earth. This is the flat Earth, sun, moon, and zodiac clock app, and the sky is a clock. The sun goes around once every 24 hours, so the sun is keeping track of the hours and the days. Wherever the sun is, it's noon. So if I stop this right now, where are you located?
Ohio, buddy.
You're in Ohio. That's right. I knew that. Actually, I believe that. I don't know it. You told me, but I never verified it. But I'm a believer, so I believe it. Okay? All right? And you believe that I'm in Connecticut because I told you. You don't know it until you verify it. That's something important to just put out there. So right now, it's noon. And
your IP address? You may, how I can prove
no,
that.
no. I mean, you can prove it. But belief is easy. Knowing takes time and effort.
Right.
Okay? But the thing is, if we had to check everything, we'd never get anything done. So there's certain things that you know, like he's not lying to me. He's in Ohio. We were talking about Canton, all right? So right now, if I called my friend in Central Australia, I'd say, what time is it and where's the sun? He goes, well, the sun's a little lower in the sky than it was a couple months ago, and it's noon, and it's right there, and that's where the sun is. So we turn the sun on. As the sun goes away, again, it takes its light with it, and it gets lower and lower, and then it literally disappears. If you and I were in a room with lights and the scattered lights in the ceiling, and you and I were in this room, 10-foot high ceilings, and I'd say, oh look, that's a Big Dipper, and that's a frog, and that's a bull, and then I'd say, okay, now expand this room to 10 miles wide, and I sent you just a couple miles away, 3, 4, 5 miles away. Well, one, the ceiling and the floor will merge together. I won't even be able to see you because in a hallway in Las Vegas, I can't see to the far end because the lights are touching the carpet in the Bellagio from one end of the hallway to the other. But you're 4 or 5 miles away. I call you on your cell phone. I say, Matt, look up. Do you see that bull and that frog and the bunny that we draw? No, I see completely different lights in the sky, right? I say, okay, turn off all the lights. I turn off all the lights and I turn the light on mine and I say, do you see the light that's lighting me up? And you're like, no, I can't see you and I can't see the light. That's in a friggin' clear room just a couple miles away. Add atmosphere in there to block that light. That's where the sun goes. So look, the sun is going around. It's about noon in Johannesburg right about now. Sun's rising over here in Connecticut. You're probably in Central Time Zone, I'm guessing.
But again, but Dave, you're kind of missing my point.
Go ahead.
Is this flat plane?
Oh, you know what? I'm not even showing you what I'm showing you. Damn it. There you go.
Is this flat plane spinning or see?
I'll answer that. We're not moving whatsoever. Calm lakes, calm water. Your senses tell you we're not moving.
At all.
So here's the sky clock. Again, I'm sorry. I was talking without showing you it. When I'm pointing to something, if I'm not pointing at it, will you just tell me, please?
Dave, you're not pointing. Now you're pointing at it.
Now I am. So look, it's noon right there in Australia, and now it's later here and it's earlier here, right? So the sun comes around. Right now it's midnight in New York, okay? And now the sun's coming around. When it's over here, the sun will start rising because it's coming closer to me,
So the
right?
sun don't move, right?
The sun moves. The earth does not move. The sun keeps track of the hours and the days. Mm-hmm. The moon, you see the moon right here trailing behind it?
I do.
Watch, I'm going to speed it up. The sun will lap the moon once every 28 days. So look, it's gaining a little distance on the moon, and as it gains distance, the moon phase grows. So the moon keeps track of the weeks and the months. There used to be 13 months of 28 days because it's a 28-day cycle, okay? So the moon keeps track of the months and the days, right? And then if I stop it and slow it down and turn on the stars also spin in the same direction. The stars are spinning just a little bit faster than the sun. So little that it takes 365 times around for the stars to lap the sun. They're going faster. So if the stars are going faster, that means the sun will slowly drift back into each constellation for about a month as it drifts through them, and in a year from now we'll be right back to where we started from. The sky is a clock. The sun, the moon, and the stars keep track of the days, the seasons, and the years. Fascinating, right?
It's fascinating that you guys come up with this.
Well, it's not that we're just coming up with this. This is, by the way, we'll get into it in a moment. This deception is less than 100 years old. They were teaching flat Earth here into the mid 1900s, right? And they just changed everything. The Rockefellers took over. It's a whole thing. And then we're going to get into it soon because you're a smart guy and you're getting this. You're going to go, well, why the lie, David? Why the lie? save that for the end, okay, right? All right, well, save that for the end because
I'm gonna definitely send you and some pot. I will send them to you, and you can distribute them as you see them. Okay.
Okay.
I am a digital Egyptologist. Okay?
Well, then tell me about the Egyptian stuff at the bottom of the Grand Canyon because that doesn't fit our narrative. I mean,
that's for next Friday's show.
Yeah.
Jared and Rex Baird
Yeah.
have actually tried to find that cave. Okay. They're like the cave is not. We can't find the cave. But I will tell you that the Men in Black were all over them from their point A start time to their end leaving. They were all over them. In case they did find it, right?
So
who knows?
You're arguing for a deceived history.
I'm arguing because I'm explaining. Going to say to you that the clock that you're presenting, okay, does not exist on something that was literally drawn and painted on a building that is 5,000 years old.
Well, we're gonna talk about that. We'll talk about that in a little bit. Okay, so let me explain the seasons why I have this open here. Can you see this yellow line here, the outer yellow circle?
I do.
That's the Tropic of Capricorn, and the inner one is the Tropic of Cancer, and the red one is the equator. Okay, the sun migrates in between these tropics. Right now, in December, it was out at the Tropic of Capricorn. So I'll go. Here I'm going in. So June, the sun will be as close as it gets to us for the year. It comes in close because it's closer. It's higher, just like a streetlight. If a streetlight was the sun and you were underneath it, you're directly under the sun. The streetlight down the road is lower and it's farther away and it has less heat. Okay? So this is our summer. And anything in between, what's this region in between the two tropics called? It's called the tropics because the sun is always close and it crosses over them twice a year. It only comes to us once a year and then it turns around and leaves. 6 months later, so right now in June, it's super hot in Miami and California and Mexico because it's summer. The sun is directly above them. It's winter in Australia, right? But 6 months later, the sun moves out to the Tropic of Capricorn. We have our winter. They have their summer because the sun is closer, higher, and it's higher in the sky because of it. Okay. The whole tilted ball thing, it makes absolutely no sense. And once you actually analyze it, you go, seasons prove the earth is flat.
Are you ready for a 2-minute break?
Yes, but sure.
Are you sure?
I was going to show you one more thing. We were talking about, you were talking about our history. So these are all the men. They're supposedly Freemasons that proved, the heliocentric model. All of their stories are absolutely ridiculous. I don't think any of them existed. I think these are all made up stories just to brainwash us into believing this heliocentric system. And then if you look at all the ancient cultures before the religion of NASA, they were all flat Earth. All of them were flat Earth until these bozos came around and said, "Oh, it's a globe. It's a globe. That's how we do it." And people say, "Well, how do you predict the motions of the planets and the eclipses on a globe?" How the heck did these guys back then, if we're all spinning and twirling and rolling and going in all these directions with these massive things and nobody's ever been to space, how did they predict any of that? It makes no sense. What they did, though, they were on a stationary Earth. The stars are fixed in the skies, except the wandering stars, which we now call planets. They're all moving around, and they notice the patterns. They notice that they repeat. They notice that the cycle of eclipses repeats every 18 years. Okay? An eclipse is nearly impossible on a globe Earth, and a repeating eclipse is absolutely impossible, but there's eclipses every year, and every 18 years, the entire cycle is redone, right? And just real quick on eclipses, this was found off of Greece It's called the Antikythera mechanism, and they actually rebuilt it. They scanned it with CAT scans and all sorts of stuff, and the scientists put it together. And it's a device 2,000 years old that, when everyone thought the Earth was flat, predicts the position of some of the planets, the phases of the moon, and position and eclipses. Right? And it works, and it still works today. If we were in a heliocentric beehive flying through an infinite space vacuum, which is scientifically impossible, none of this would be predictable.
Wow. Okay.
There you go.
Well, whenever we come back, yeah, I'm serious. Give us 2 minutes, 24 seconds for a potty break. You can fill your coffee or whatever you want to do. And whoever is in here would like to talk to Dave, got questions for Dave.
Yeah, I'm sure there's some flat earthers in the chat. I want to hear from the people that think this is stupid. Ask your question, but ask it nicely, because if you don't ask it nicely, I'm not going to answer it nicely.
Well, this is the thing. Like I said, Dave, I am a very open-minded individual, and I hope by now you can see that.
Don't be so open-minded that your brain falls out. Think, right? Think.
Smartass. Go grab your coffee break, and we will be right back with Mr. Flat Earther David Weiss.
Weiss like ice.
Weiss like ice. Showtime. Alrighty then. Hopefully we're back. I don't think we lost Dave. I don't believe that we lost Dave. I don't believe that we lost live feed. All right, so here's what we got.
I'm here.
All right, you're there. Somebody's up in the chat saying, glad that we've got a show that talks with balls for truth. Yeah, I mean, again, Dave, got Mr. Stacy Burns in here. I do believe Stacy with a, I do believe that's spelled as in like male. Nevertheless, I don't want to insult. I'm going to go ahead and unmute Stacy.
All right, and somebody in the chat said, "How come we don't see the sun? Go back and watch what we talked about. I fully explained why you don't see the sun."
Somebody in the chat said,
"How come you got to turn your sound down?" Go back and watch what we talked about. I fully explained why you don't see the sun.
All right, Mr. Burns, welcome to the program.
Yeah, give me a second. I got my mic next to my speakers. Let me change my mic.
All right.
So, yeah. How we doing? Can you hear me?
We are doing well. What's going on, buddy?
Nice not too much. I'm getting home from a long day. I was told to come on here and ask some questions, so here I am.
Sweet.
Okay.
Welcome.
Awesome.
So,
Stacy, what do you do, or what's your connection to this?
Well, I'm a farmer by day.
Okay.
I've been just a backyard astronomer for, I don't know,
Great.
20 years or so. So
Great.
I do astrophotography, and I teach kids about science of all kinds. We homeschool, so we run a co-op here, and we teach science and survival and farm stuff. But I started as a visual observer as a young man, and basically sit on a tractor at night, and look up with binoculars and kind of try to just see what I could see. Hell, I was hoping I'd see a UFO or something, but later on I got a big telescope, and then I learned about photography and got a cheap equatorial mount, started taking pictures of the night sky, and so now we have little contests and stuff. We get published in magazines, and we just all do it for fun. It's really pretty simple, and pretty much anybody that comes out here, we have star parties pretty regularly. So it's definitely not rocket science like a lot of people would have you make it out to be.
I
guess
agree.
My question would be is if we're going to have a flat Earth, I would like to know exactly why, when I move south, the stars, like Polaris, for instance, never really moves that much to our appearance. It's the North Star. It's pretty easily visible. As we move south, like if I go to the Texas Star Party, we all have to align our equatorial mounts to that to counteract the Earth's rotation, or at least so in our minds, right? So
Right.
What I want to know is why when I go to the Southern Hemisphere, do I have to polar align to the Southern Cross? And why are the stars completely, totally different if we're on a flat sphere? Then how come I can take images of completely different targets that there's no way we could ever see from anywhere in the northern hemisphere. And we have to completely switch our mounts around, face them south, and everything's backwards, see? So all of the targets, all the nebula, everything up there, even galaxies we image, anything that you want to look at through an eyepiece of a telescope that you're using a basic tracking telescope with, that you can, like a cheap Celestron Astromaster from a expensive, nice piece of equipment that you can take on an airline with you. It doesn't really matter how expensive or cheap it is, but you have to align differently from the southern hemisphere.
If the Earth was a sphere, Polaris is our North Star. Nobody should be able to see it south of the equator. Would you agree with that?
Well, right, yeah. At the equator, if you say theoretically zero,
it would.
It's basically on the horizon, and you don't even have to have an equatorial mount, because your mount can actually just be.
I'm not talking about that. I'm not talking about that.
Use an alt-az mount.
Right. I'm not. Forget the mount. I'm just talking about. Is it possible to see Polaris south of the equator?
No.
All right. There's a I forget the name of the observatory. 30 degrees south in South America can see Polaris. That's impossible on a ball, right? And the explanation they give is refraction. It's refracting up over hundreds of miles of curvature and plopping itself in the sky on the horizon, right? I don't buy it.
Atmospheric refraction, sure.
Yeah, well, that's a cool story, but it doesn't hold water. Here's the other thing. If you think about sizes, okay? Now, if this was our sun, how big would the Earth be? It'd be a little pebble next to it, right? Tiny pebble, right?
Sure.
Okay. So if I had the sun, if you were on a pebble, it's on the tip of my finger, and I had the sun this close to the Earth, and you looked up, the sun would fill your entire sky, horizon to horizon. Agreed?
If you were that close to it, sure.
Yeah, absolutely, 100%. So I'm just setting the base here. So it's filling the entire sky. We move it 93 million miles away. Why is it getting smaller? Easy question.
Because you're moving away from it, it's getting smaller.
Perspective.
Because from our angular perspective, the same reason the sun appears larger as it enters the horizon is atmospheric refraction.
So it gets smaller, 93 million miles away, which is 8 light minutes. What if I double?
It's said to make up 99.8% or 99.9% of the solar system.
Yeah, so that's not what I'm asking. What, the sun is 99% of the whole solar system?
Yes, actually its mass makes up 99.996% of the entire mass of the solar system.
That's a fun story, okay? So I move it 93 million miles away. It goes from filling the entire sky, horizon to horizon, to the size of a coin held at arm's length. Okay? So that's a pretty big reduction. And 93 million miles is 8 light minutes. If I made it twice as far, how much smaller would it get?
Well, if you made it twice at twice the distance, you'd think it would be half the size, but I would need to know the math from that.
Right. So what we'll do to make it safe, 24 times the distance. Right? 24 times the distance is 3 light hours. At 3 light hours, the angular size of the sun is scientifically provably too small for the human eye to see. Okay? Also,
now wait a minute. If it's scientifically proven, then why can I see Saturn through a telescope?
100%.
The satellite takes several hours for the data to get there.
So hang on. One thing at a time. The angular size of the sun is too small to see, right? It's provably magnitudes too far. All right. So, do you know what the inverse square law of light is?
I'm sure you're going to tell me.
Right. Well, I didn't know when I was first asked, so don't worry. It's when you have a light. So let's say this ball has one. If I put a light meter all on it, it's one lumen. Well, if I let the light come out to twice the diameter, it's now 1/4 of a lumen because it's 1/4. It gets quartered every time you double the distance. And if I double that size, it's 1/16 or 64th or whatever it goes down to. It just reduces. So when you move the sun to 3 light days away, the brightness is an issue. But we're not even going to go there, okay? We're just going to go with its angular size, too small for the human eye to resolve. Polaris, on the other hand, they say is 48 times bigger than the sun. So the distance that we would have to move Polaris to make it provably impossible to see with your naked eye is 6 light days. 48 times 3 light hours, 6 light days, okay? At 6 light days away, Polaris is scientifically provably too small to see, ignoring the inverse square law problem of light, and they tell us Polaris is 433 light years away. This is This is scientism. This is numbers that they don't teach you to process these numbers, so you just go, oh, this guy in a lab coat told me, so it must be right. This is provable. Now, let's talk about the ISS for a minute. Okay?
Yeah, I can image the ISS, actually. You can watch it pass over. I can calculate its pass with Orbitron, and with any telescope, you can basically image it as it goes across the night sky.
Well, you can't.
Solar panels and stuff. You can do that with a pretty basic telescope.
So what are you seeing? The question is, if you can't touch it or measure it, you don't know how big it is. But they tell us the ISS is about. Oops, that's not what I wanted. Hold on. They tell us the ISS is about the same size as a 747, maybe a little wider. All right. Here's a shot of a plane passing transiting the moon, and here's the ISS transiting the moon. Well, we do know one thing. We know the sizes of them. So therefore, these moons are about the same diameter. All right. Therefore, these two things, because we know the size, because if we didn't know the size, we could say, well, one's 10 times farther and 10 times bigger. Like they tell us the sun is 400 times bigger and 400 times farther than the moon.
Well, that could potentially be misleading because on the one side, you've actually shown a more orange moon. And if it's lower in the horizon, your atmospheric refraction would take into account a much larger version of the moon that you're flying across, see. And when we're talking about that satellite there, and a couple of ways we can identify how far away it is, which I think your math's a little off there. We can debate on that if you really want to get into that. You've kind of slipped up in a few spots. The problem is I can take any amateur ham radio operator knows that we can use simple SWRs, and they will actually call you back. And what happens is the time from your hello ping to your return ping, actually you can calculate the distance between you two. And something amateur ham radio operators do on a regular basis is make contact with the International Space Station.
All right, so hold on. We're going to get into the International Space Station. You're throwing a lot of stuff out there, which is just things that you've been told that you haven't verified.
It's things I do myself. I do myself. So things I do from my backyard.
But these things work on a flat Earth and on a globe Earth. Okay, but let's just get into it. So you disregard that this could be because it's lower on the horizon. That's an interesting point. I'll take it, and we'll have to get one where it's both at the same height in the sky. But
Perspective.
Yeah. So I get it. So if you ever stand next to a 747, it's gigantic. It's huge. If you're standing next to one on the ground, but at cruising altitude, it's a tiny little dot, and you can't even see the engines on it, if you will. Right? So, are you with me?
Well, I mean, with a pair of binoculars, you can see.
No, with your naked eye. With your naked eye.
Well, since we're on that topic, a 747
depends on the atmospheric conditions and stuff. But I mean, if it's cruising at 35,000 feet, you're right. It's pretty much just a dot in the sky.
Great.
Stop.
Go ahead.
I gotta throw this out there because we've got a lot of listeners right now.
At nighttime, you can see.
I need to finish this point.
No damn 747.
The red and green light will have, because all planes have it. I'm a drone pilot.
So let me make my point.
Green on one and red on the other, and
let me make my point. Let me make my point, and I would love to hear your response to this. So at cruising altitude, the 747 is a tiny little dot in the sky. Kind of hard to make out the engines. Maybe you can. You probably can't read what airline it is, but that super clear day, maybe you can. If you doubled the height, it's scientifically provable that it's too small to see. If you tripled the height, it's worse. The ISS is 50 times farther away than a 747 at cruising altitude. 50. That is scientifically provable, impossible to see. And then
that's why it just looks like a point of light.
You could not see it. You can see it with your naked eye, and I'll tell you why. Because it's a B-2 bomber, right? There's 5 of them that they have remodeled, that they have made parts of them transparent.
You should make a trip to the observatory sometime. It's in the backyard.
Well, listen, we've done it. We've transited.
Very own telescope at it. I'll help you get it pointed out. I'll put a laser on it, and I can show you how to communicate with it. Even
how to communicate with the ISS. You want to?
Yeah, they'll actually ping you back. They'll say hello with a simple look up. Anybody who's watching, you can take a cheap $30 dongle from Amazon and run an antenna outside. It needs to be a specific antenna. It's not very expensive, and all you need to do is learn how to use SDR, software defined radio, and you're going to be broadcasting a signal, and you're going to say hello basically to them, and they will ping you back a hello. And
let me ask you an honest question. Yeah. You don't think that they can fake that?
Oh, I'm sure they could.
Okay.
How are they going to fake me seeing the point of light moving across the sky?
Because there is a point of light moving across the sky. I'm saying it's an airplane.
The telescope directly at it.
It's an airplane. It's an airplane.
And literally seeing it with my own eyes.
It's an airplane disguised to look like it's an airplane. So the other thing is when you're looking
at. We do it all the time.
Listen, I've seen it. I've done it. I've watched the ISS transit from horizon to horizon. I've watched it appear, and it took about
telescope. You can see it.
I can see it with my
clear.
So hear me out. When it transits the sky, it's brighter than any star in the sky. It's super bright. How is it reflecting sunlight to my eyes and to everyone's eyes, no matter where they are throughout Connecticut? How come after 8 minutes of it transiting, I can still see it, but my friend in California can't see it because it's going 17,500 miles an hour. It should be over California already, but I can still see it in Connecticut. Okay.
Orbitron actually calculates very precisely where it's at. And what you're doing is taking its distance, and you've gotten your math a little off, and you're greatly overestimating our ability to see those things. Or underestimating our ability to see those things. What I'm trying to tell you is anybody with a cheap telescope can see the ISS.
No, what you're seeing, you're seeing a magic trick. They're showing you. They're showing. Oh, how do you know that? How do you know that?
Because I've seen it with my own eyes.
Yeah, I've seen it with my own eyes. It's an airplane. You cannot. Here's the thing: the fact that you can see it. No, the fact that you can see it with your own eyes proves that it's not the ISS. The ISS, the angular size, is magnitudes too small for your eye to see, but you can see it with your naked eye. See,
we watched the Falcon 9 Heavy. We watched.
Oh my God!
You can literally see them dock. You can make out the individual pods.
Oh, I'd love to see that. All right,
it's all over.
But
here, any astronomy club.
Here's the thing. Here's the thing.
They'll be more than happy to see.
You cannot see something that small that distance. It's provably.
I think the evidence would be overwhelmingly alarming for you if you would just join a local astronomy club. Find someone that is not some official, find a backyard good old boy, sit down and have some beers with him, and let him show you the night sky. I mean, really, this is going to help you out a ton.
Stacy, you've been indoctrinated pretty well. They've tricked you well, and
I did my own research. I'm a dirt farmer. I actually did my own. If you look up astrofarmer.com, them are all mine.
All right, let me ask you a question. If you catch NASA faking being on the ISS,
NASA any more than you do.
Okay. So, but you believe that they're pinging you from the ISS. Hey, Stacy pinged me from his trailer, so I'm gonna ping him back. The astronauts that are doing the science on the space station. Let me show you.
One thing is I know a thing or two about ham radio, and I'm guessing that you don't.
Stacy, I'm going to show you what goes on the ISS. If I show you that they're faking being on the ISS, will that maybe make you scratch your head on who's pinging you?
Well, I'm an astro imager, so you can show me pictures, but be aware I might be able to pick them apart.
All right. So what's going on here? Okay, well, that's the wrong one again. So so here's a scene. Don Pettit, the astronaut, right, brightest guy they've got, made a cup out of a piece of plastic with coffee in it, and he basically, this is being done with computer graphics, and all of a sudden the coffee got out of sync with the cup. Okay. It got out of sync, right? This is showing you that they're layering this stuff. They're faking it. Let's look at another one. Here's Chris Hatfield singing. These guys are in front of green screens. They're in separate rooms. This guy with the microphone misplaces where Chris is and sticks the microphone directly inside his neck. Okay? Right now, the microphone is in his neck because this is a layered video, right? They're trying to show us something really cool, and they can't. So here's another one. This is these guys are
play a video game online and experience something called lag.
Let me ask you a question. Is this guy in the background floating by, or is he clearly on a harness where you can see the wires in the harness? Right? These guys in the foreground are flipping their stuff around, and then for effect,
I see the thing on his butt.
Yeah, so they had this guy float. Hey, you got to let me finish what I'm saying, okay?
Why would it not have a reason to stick up?
Why do they have a wire on it? Okay, he's hanging from a wire, and they didn't expect anybody to zoom in, right? And then these guys are flipping their microphone and his hat around. See his hat here? In the script, he's supposed to pass his hat to this guy, and the guy's supposed to put it on the wall.
No, I understand your argument.
Watch what happens. Watch what happens. Watch what happens. Watch what happens. He moves his hand, and he. Which argument do you understand? What was the point I'm trying to make?
Well, the point you're trying to make is that you don't believe this is real, because basically all this stuff, if you really wanted to simulate it, any fighter pilot or any pilot knows that you can simulate this. Hell, you can go pay money and actually get on a plane where you can experience zero gravity.
Exactly.
You think that they're not up there. The problem is when it comes to the evidence, basically the flat Earth entire criteria can't really predict anything.
What do you mean it can't predict anything? We've been predicting everything before they came up with this stupid heliocentric model. They were teaching flat Earth here in the United States up until you know what? You got to let me finish a sentence. Are you deaf? I can't finish a sentence. Let me finish a sentence. I let you talk. Let me talk.
All right, talk away.
They were teaching flat Earth here in the United States into the mid 1900s. Okay, go talk to really old people now, and they'll tell you, okay, that this entire deception is a new thing. All right, and there's zero proof of the globe. Now, looking up at the sky at a plane flying by and believing it's ISS because they took the time to ping you back is not proof of the globe. What would be your number one proof of the globe?
My number one proof of the globe is I've traveled from the northern hemisphere to the southern hemisphere. All of my targets were different. And when I go and check my maps for what I want to target, essentially they're all very precisely where they want to be. And they do that based on a system that's been so scientifically backed up by facts and prediction.
What facts? What scientific parts are you talking about?
We can predict eclipses anywhere in the world for centuries. We can predict when a moon's in an eclipse, which isn't all that fun.
Hold on. Let me just respond to that. Who predicts eclipses? Do you know that there's one guy?
Stellarium on your computer. It's free for download. It's open source, so it's actually built by community members.
I know what Stellarium is. I have Stellarium, but if you go to NASA's website, you'll see that one guy, Fred Asperneck, does all of their predictions. He uses the Soros cycle, which came from the friggin' Antikythera mechanism, which discovered off Greece 2,000 years ago. I mean, that's 2,000 years old.
Does all that?
There's one guy. There's one guy that does it all. Go look at NASA's website, unless NASA's lying, of course.
There's not one guy. There's about a whole group of people. It's open source. The deal about your prediction models is there's several universities, and I got to say I don't always trust universities and stuff like that. I like to find out for myself. But no, there's a ton of places that do that, not just one guy.
Let me ask you a question. Does the gravity of the sun hold on to the planets?
Well, the sun has its own orbit. It actually orbits around a very small circle. And yeah, the sun, if you could imagine a towel and putting a heavy bowling ball in the middle and everything's flying around it, yeah, it essentially keeps everything in check as we fly on the plane through our own galaxy. Yeah.
Well, you're talking about the bending of space time, right? Yeah. So
there's 4 dimensions.
So why does it go down? When you put the bowling ball in a towel, why doesn't it go sideways or up? Why is the towel? What tells you that down is down? Why does it bend it one way?
Well, there is no down in space. That's what's great. But what's holding it?
Well, why does it bend it one way? This is theoretical nonsense. All of the stuff you're saying is theoretical nonsense. All of it. So let me finish.
No, I can share with you a great number of things we don't know.
Trying to make a point.
There are some things that we do know, and I think if you spend an evening at just a backyard astronomer. And let him.
I took 4 years of astronomy. I took 4 years of astronomy at university, right?
Well, that actually makes you less of a candidate. I took 0 years, and I astro imaged from my backyard. If you got into this, the deeper you got into this, the more that you would know.
Jason, as well as David, can we please come up here and let welcome Wayne Stewart, Mr. Wayne Stewart.
Hey, Bat.
Hey guys, it's been great talking.
Yeah. Jason.
Hey, Jason.
All right, can we move on? We'll move on to Wayne because I'm unable to make the point.
Thank you, Mr. Burns. Appreciate you. All right, Mr. Wayne Stewart, how are you, sir?
Wayne, can you come on? Right. Can you come on camera, Wayne?
No, I look like hell. I don't do cameras.
Yeah. I
don't think you want to see me in my boxers.
That's all right. We can chat, but I don't really debate people off camera. So go ahead.
Oh, well. All right. I was watching the video earlier. I've got some connectivity issues out here, so I had a heck of a time getting connected. Watching that sunset video you were showing, and it doesn't look like that when I watch the sun go down. It doesn't get smaller as it approaches the horizon.
Well,
it stays relatively the same size as far as the amount of space it takes up in my view range.
Yeah, so
I don't trust that video. A video that makes the sun get smaller as it goes away doesn't work because it doesn't do that.
Well, actually,
to my own eyes, it doesn't do that.
Actually, it does do that depending on the weather conditions and where you are. If it's super dry and clear, the sun literally sits on the horizon and it goes away and it gets smaller and smaller. However, if there's moisture, if there's something higher than your eye line, it will go behind that. And an example of that, let me show you an example, a good example. I have my drone up. It was below freezing, super clear day, and the sun went down, 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 down. And instead of just keep going because we're spinning, it literally, in 5 minutes time, it went from up here to here, and then it sat here for 10 minutes. Now, it just sat here. Now, my friends were at the beach. They saw the sun set from the bottom up due to perspective because they were looking at trees, 5 miles across the water that were above their eye line. But I just watched the sun sit here, and it kind of just went into the soup of the atmosphere, and it just took its light with it. It could no longer push through. This proves right here, without a doubt.
I've never seen that.
I know, but have you ever
I've watched sunsets for 60 years?
Let me ask you a question. Have you ever put a drone up at I forget the height I had it at, 3,000 feet or whatever it was, on a super clear day with no humidity and watched the sun to the very end and then zoomed in on it? Have you ever done that? No, you haven't. Most people haven't. I did it.
I haven't done that. Have you ever watched the sunset from 30,000 feet?
Yeah, I've done it. I've done it on an airplane. So
it looks the same as it does from the ground.
No, it doesn't. It goes much. It's much longer. There was a flight from I think it was from California to Germany, and it literally chased the sun the whole way, and the sun never set. It almost set, but then it came back up. And if you watch the path on this thing,
you were chasing it.
Yeah, but we're not diving over a curve. The gyroscope on the airplane keeps it straight and level. And we don't nose down. We'd have to nose down a mile every 2 minutes at 550 miles an hour. Nobody ever does that. Airplanes fly straight and level over the Earth plane. The Earth is not spinning. If
your altitude is measured from the surface of the Earth.
Yeah, so
it's going to be what it is.
What am I looking at?
You're looking at this is a time lapse video out of the pilot filming the sun as they're flying to Germany. Okay.
Can you provide that video?
I'll show you where it is on the app, and then it's on YouTube, and you can look at it, and it's high def. So at the equator, the Earth is spinning at 1,000 miles an hour. In Alaska,
1,000 miles an hour is not a rotational measure.
Yes, it is. It's 1,000 miles an hour. It's not the angular speed; it's the linear speed.
Yeah.
Okay, so linear speed is linear
related to your circumference.
Linear speed, absolutely. Very, 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 very good. Good answer. So I was going to say, if you're in northern Alaska and you're sitting on a runway, what's your linear speed there? Do you know?
I'd have to calculate it.
All right, great. It's like 300 miles an hour. It's something about that.
Yeah.
So here's a question for you.
Because the circle of the Earth is a lot smaller up there.
You know what?
Thing on the south end.
You got it. Very good. Very good. So if an airplane takes off from Alaska, flies to Ecuador, and wants to land on a north-south runway that's moving sideways at 1,000 miles an hour, where does it get that extra 700 miles an hour of sideways momentum from?
The atmosphere is moving mostly with the Earth.
So the atmosphere. Hold on.
The atmosphere and the Earth is wind.
Yeah. So the atmosphere is moving with the Earth. So a summer breeze can blow the air left and right. Do you know that the winds at 40,000 feet outrun the spin of the Earth? Okay, that makes no sense.
Yeah,
it makes it makes no sense on a spinning ball. It makes sense on a flat Earth with, toroidal energies coming out, but it makes no sense on a spinning ball. You would not be able to land on a runway going sideways at all, because with the runways moving sideways, how are you going to gain that 700 miles per hour sideways speed?
The toroidal energies have something to do with that as well. There's a whole area of physics that we're only touching on now. Every material object, from the smallest subatomic particle to solar systems, galaxies, and quite possibly the universe itself, has a toroidal-shaped energy presence about it.
This is hypothetical, theoretical nonsense. You have no proof of this. This is what you read in a book, and what the controllers of this world told you.
No.
I never read that in a book.
How's that read in a book whenever you can actually measure the energy from the toroidal field?
Well, you can. That's here on the flat Earth. That doesn't prove the Earth is a globe.
It is also shown on an aurora borealis, and an aurora borealis will indeed show you the curvature to whatever you're looking at, whether it be a dome, whether it be a whatever.
What curvature?
Bingo. There's a curvature to something above us. We can see our own atmosphere. Do you realize that, right?
Yeah, well, we see the same distance in all directions.
No, you didn't hear me. We can see our own atmosphere. Our own atmosphere has got a curvature to it. When it is illuminated by the aurora borealis, which is, again, electromagnetism through the toroidal field, the positive negative polarity of the planet, that is what causes the aurora borealis. Inbound, outbound, central force, fusion energy.
This is what you're told. This is what you're told.
Hang on. Okay. No, this can actually be measured. There's measurement tools to this. The same way that you have provided tools in the measurement of chasing the sun. The same way that you showed that you've followed the sun from point A to point B, and it got smaller and smaller. There are tools, right, that can measure the toroidal energy.
That comes out of the center of the flat Earth. I'm with you 100%.
Okay. What's below that? Let's shift gears here. What is below our flat plane of existence?
You tell me, since the deepest hole ever dug is 7.5 miles, which is equivalent to drilling through halfway through the skin of the apple, and when they did it, they used ground penetrating radar that was wrong every step of the way. So when they were going halfway through the skin of this apple, just for comparison, they couldn't guess what they were going to hit next. They hit an impenetrable barrier, and then all of a sudden they know what the next 4,000 miles is? Okay? How did they come up with the radius of the Earth in the first place?
It's actually quite simple. If you take people on 3 different locations of the Earth and measure the angle to the sun at the same time, you cannot get those lines to intersect unless you curve the surface of the Earth.
See, that's incorrect.
And that curve approximates the diameter. That's not incorrect.
Yeah.
If I'm sitting here looking straight up at the sun at solar noon, and I get somebody 300 miles west of me and ask them to measure the angle to the sun at exactly the same time, they will come up at a certain angle. I don't know what it is right now. I haven't calculated it. And that's fine. Those 2 lines will intersect at a point, and they can even let you triangulate and calculate the apparent height of the sun from the surface of the Earth.
So are you
get a third person 300 miles farther and have him do it. And you will find that those lines will not intersect at one point until you bend the surface of the Earth into a curvature that approximates the global radius and diameter of the planet.
Okay. So you're assuming that the sun rays are coming in parallel from a distant sun?
No.
Oh, they're not?
I'm assuming the sun rays are coming directly to you. And I'm assuming
No. But are the sun rays... The Earth story only works if the sun rays are all hitting the Earth parallel with each other. Now, where you are on the Earth...
They're not parallel.
They're not parallel.
No, he's actually explaining to you the different perceptions of measurement perception. You can literally measure perception. You realize that?
Here's the Earth. Here's the sun. The sun is a distant sun. According to the heliocentric model... Here we are. The sun's so far away that all of the sun rays come in straight. So if I'm right here on the equator and it's equinox, the sun rays are coming in perfectly. But if I'm over here, I'm tilted, so the sun rays are coming in at an angle. But the sun rays are all parallel.
So now you're saying light does not bend.
They're more or less parallel because the sun is significantly larger than the Earth.
Right. So
did you catch what I said? Light bends, Dave. Light bends to magnetic flux.
Light bends as it goes through a different medium, as it comes into the atmosphere. I mean, nobody has ever seen...
Gravity also bends light.
Nobody has ever seen parallel sun rays.
But you just admitted it, Dave. You said we've got an atmosphere.
We have air above us, right? The sun is within the Earth system. It's not outside of it. Okay?
Okay. All right.
So... how did they come up with the radius of the Earth? So you're saying, how did they come up with the radius? You're saying you got your 3 sticks and you bend it, and it works. That doesn't prove anything. I mean, that's like Carl Sagan on Cosmos,
well,
where he showed
what it disproves is the flat Earth, because on a flat Earth model, a single object in the sky, if you measured the angle to it from known distances in several directions and several distances, it would all add up on a flat model, and it doesn't.
Actually, it does.
No, it doesn't. If I'm looking at the sun straight overhead now, and you go 300 miles east of me, and you look and you measure that angle, and you go 300 more miles east, and
it's a different angle. Different angle.
Well, of course, it's a different angle, but then you draw them on a piece of paper and draw your lines. Here's the angle I saw it from here, here's from there, and here's from there. You would expect the lines to all intersect at the same place because you're all looking at the same object.
No, I do not, because I don't believe we're looking at the same object. We all see the sun in a different position, and I'll show you how that is, okay?
There's only one sun, right?
There's only one sun, but we all see it.
Then we're all looking at the same object.
Okay, so I'll show you that.
It's insane to say my sun is not your sun.
So
it's the same sun.
So here's your 3 different angles, shadow lengths, right, with a small local sun. No shadow, little shadow, bigger shadow, longer shadow on a flat Earth, right? Aristophanes supposedly did this. They did some math, figured out the sphericity, but the math would be the same here, okay? So...
No, it's not the same, because that farthest guy to the left has a much straighter up angle than the farthest guy to the left on the globe model. You go far enough around, and you guy can't even see the sun. At one point, it's 90 degrees. It's setting. It's on the horizon from my point of view.
Can I say something to this image that I'm looking at?
Go ahead.
The sun, you're not actually showing the position. A lot like the perception of the airplane.
This one.
Go left. Go. I'm sorry.
This one.
Yep, right there.
Because it's a distant sun on the heliocentric model.
Okay, so the one to the left is not a distant sun. Is that what you're saying?
Right.
All right, so that's the sun that we're all under, you're saying?
Yeah, the sun is small and close to in the flat Earth system. Okay. So let me explain how I believe that we see the sun. The sun is for lack of a better word, the sun that we see.
Look at the image that you've got to the left, okay? And I want you to think about a sunrise and a sunset given the image that you're showing.
Here.
Nope, right there.
Yeah, here.
It would not work.
No, you're incorrect. I already showed you. You didn't see it. I showed you. I showed you how the sun sets when it goes away. I'll show you again with a different example. Okay. Maybe it'll show you a little bit better. But so when we see the sun in the sky, just like sometimes you see a sundog. It's like, wow, is that another sun? No, it's just the atmospheric conditions. I call it the sky sheet. So here's a little experiment I did, and amazingly, it looked very similar to the sun. So here's the sun. This is the sky where we see the sun. So my girlfriend is to my left, and I said, hey, where do you see the sun? Point to the sun. And she points, and she points, ready? Here it goes. She sees the sun there. I see the sun over here. I move over there. That's where she sees the sun. But when I'm over here, I see the sun there. That's how you can't triangulate the sun, because different people see it in a different position.
Pointing to the same object.
Yes, she is, but we see it in two different positions. This is a light 10 feet on the other side.
Two different positions.
Right, but we see it in two different positions. Okay, this light is a flashlight 10 feet behind, right? But we see it here. We don't actually see the source. We see it manifesting here, and we see it in two different positions. That's why you cannot triangulate the sun. No one's ever been able to do it.
Now, are you looking at a reflection, or is it on a translucent surface?
It's on a translucent sheet. Like I call it the sky sheet.
Okay, well then what you're looking at is the place where the light from the flashlight intersects the sheet that is pointed to you. And
correct.
Yes, of course, those are going to be different.
And that's how we see the sun.
At the same object.
That's how we see the sun. That's how we see the sun.
Pointing at the same object.
That's how we see the sun. That's how we see the sun. The source sun is behind the sun that we see, within or above the firmament. Let me ask you another question. Let's change, because we can agree to disagree on this. How do you have a vacuum of space adjacent to a high pressure atmosphere without sucking all the air off the Earth?
It's called gravity.
Gravity.
We don't really understand what it is, but we do know how it works.
Very good. Very good. So, well, actually, that would be interesting to hear. But how come, when I can take the weak vacuum of my mouth and lungs, I can take a straw and suck water and air up and away from gravity effortlessly?
Because you're actually being helped. You have the air pressure. You create a lower pressure in your mouth, and the air pressure pushes the water up the straw.
Absolutely.
That's
so how come the vacuum, low pressure of space, which is way more powerful, how come it can't suck the air up and away from the Earth? And are you going to say gravity?
The mass of the Earth gives air weight. It does have weight.
So the air has weight.
Pressure, lower altitude.
So air has weight, and the gravity, the vacuum of space above it is unable to pull it because gravity is holding it down. Is that your story?
Yeah.
Okay. So in your world,
he's going to go with a vacuum in a container.
No, in your world, if I had a shoebox and I had it in a room, and I sucked all the air out of the room, the shoebox would remain filled with air because gravity is holding the air in the shoebox. That's what's happening in your world.
No. That is not what's happening in my world.
So why does the air lift up and away from gravity to fill the room?
It's all about air pressure.
No, air pressure.
Air is fluid.
At what altitude? At what altitude will it not leave the box?
It's going to make it in the box whatever the atmosphere around it is.
Okay, so in space, there's no atmosphere adjacent to atmosphere. So where in
a flat
science
Earth model that wouldn't work?
Right,
the globe model,
right.
Gravity in the center of the Earth, it works fine.
Well, you
There
believe
is
space
no
is
edge.
you believe space is a vacuum. I don't believe there's an edge, right?
I
You
don't
believe
think it's a vacuum. I don't think it's a vacuum. I think we have a substance that everything exists in. They used to call it the aether.
so space now has air. Space now has air.
No, it's not air. Ether is not air. It is an energetic substance that we used to use to calculate things, and they decided it wasn't right, but now they're going back to it, believe it or not.
So aether has enough pressure to hold the air. So space now has pressure holding the air to the earth.
Aether doesn't hold pressure.
So why doesn't the air equalize like science says it should and go off into space? And you're saying gravity.
Because the mass of the Earth is sufficient to hold an atmosphere.
Can you can you show me an experiment in your place or in any lab or anywhere that can show me high pressure next to low pressure without a physical barrier?
The universe itself?
No. You can't just say that. Where can you show me any example of high pressure next to low pressure without a physical barrier?
What keeps the ocean from flying away?
The ocean is sitting in its basin. The land surrounding it.
You are familiar with the different pressures you get at different depths.
Absolutely. It's more dense on the bottom. If I had a tank of gas.
Just like the atmosphere.
If I had a tank of gas, it's denser on the bottom, lighter on the top in the gases. But guess what? It's in a container. Right? If I open that container at any point, all the gas is going to come flying out of it.
Why is that?
Because
Mister, I'm serious. Because now you're sounding like a physicist. You are literally sounding like a physicist.
Thank you. Because I've been studying this stuff. So the reason is
very obvious.
The reason is the gases will equalize if given the opportunity. Right? Where next to a vacuum, this is impossible. This is impossible. There's nothing to contain it.
I agree with you.
In the flat Earth, I believe that we're in a container. I don't believe that space is a vacuum. I believe space is liquid. NASA kind of tells us that by all the terms that they use. Ships, docking, the Sea of Tranquility. They're talking about all sorts of nautical things.
You don't think that the electromagnetic vortex that the planet produces, okay?
What electromagnetic from
the positive to the negative polarity of the planet, the South Pole, the North Pole. Your flat plane has got a beginning and it's got an ending somewhere.
Does it? Does your universe have a beginning and an ending?
You just showed me that your drill stopped at how far?
Your drill stopped at 7.5 miles.
Okay. So
our drill stopped.
Our drill stopped.
So you don't know what's below 7.5 miles, and neither do I. So stop claiming that the Earth is a magnetic, molten magnetic battery. A molten magnetic.
No, don't put words in my mouth.
No worries.
I didn't claim
no worries.
That. I did not claim that. I'm telling you, the probable possible, okay, is that we are on something, somewhere. Okay, something, whether it's a container or not, space has obviously got density. Because if it did not have density of some type, you're right, shit would fly off the planet. Even as we're flying through the space, okay, our universe is within a completely, if you would call it some kind of a catatonic state. It's just flying through space, unknown. We're held by, right? We are held by and surrounded by, what is it called? The Van Allen belt. There's multiple belts. There's the inner belt and the outer belt. Right? You understand that? No, why did you put your glasses on?
Cool story, bro.
But see, all of the shit that you're telling us is a cool story.
I'm actually showing you other explanations. And so you believe we're spinning. So hold on. Let me just go.
Dude, you know how this is my show.
Go ahead.
I have literally spoken about probably 10 minutes
go ahead. Absolutely right. I apologize.
You guys have got everything mathematically against, literally every single thing against what has been scientifically backyard astronomy proven. Jason, Stacy came on here as a backyard astronomer, and you done everything in your power to prove him wrong, and he experienced it.
Matt, he didn't. No one has produced anything scientific yet. They say, I saw the space station. Well, scientifically, you can't see the space station, but he wants to ignore that. All right.
Obviously.
So hold on. Let me finish my point. My point is, name something scientific that proves we live on a globe, right? Because a globe in a space vacuum is impossible. Right? Name something scientific. And has anyone answered where we got the radius from? All right, go ahead.
Well,
explain why.
I tried to, but you weren't going to let me finish that one. I want to ask you something. We have the pole star on the north, Polaris, and the night sky apparently rotates around that. Mm-hmm. How do you also get the night sky rotating around Sigma Octantis in the south?
Yeah, that's a great question. And
rotating the other direction.
Yeah. So the first thing I like to say is looking at the sky is no way to prove the shape of the floor, but in the app here, if you click
if you were to
I'm going to answer it. I'm going to answer your question.
Or with a dome over it, it doesn't work on a dome.
I'm going to answer your question. Okay. So in the app here, and this question mark, if you hit that, and then you hit Southern Star Rotation, which is right there.
I can't believe you guys got an app for this.
Yeah. So Southern Star Rotation, these are videos that you won't be able to find on YouTube, because if you search like Flat Earth Southern Star Rotation, these won't come up. None of them will. But these videos here by some very smart people, the second one by this guy is amazing. This one you'll love. He uses all the calculations and everything. This guy builds a model showing you how we see the southern stars. Again, we can't go up. We can't touch them. We don't know how big they are. We don't know how far they are. So again, I don't look at the lights in my ceiling to describe the shape of my floor.
But Dave, the guy that you were just talking to, does know how to measure the distance of the stars. Yes, he does.
Now, he doesn't know how big they are or how far they are. Everything is scaling.
Yes, he does.
No, he doesn't.
Yes, he does.
Incorrect. How does he figure out the size of the stars without knowing the radius?
What, I don't have a lot of money, but I know you're in Connecticut. Yeah. I will give you the gas money for your ass to get over there to Missouri to literally watch. I'm telling you, spend 15 minutes with Jason in his backyard, and I will pay for that fuel. Make me that deal?
I'm not driving to Missouri, dude.
Well, then listen, you need to spend some time with some backyard astronomers like him that have got the capability to literally measure from my front porch, where I'm sitting right now.
NASA can't measure the size of stars. They lie about what they're doing. They say
I'm sorry. Don't listen to NASA. Listen to Jason. If you go to your neighbors, listen to your neighbor, because your neighbor can absolutely tell you the diameter of a sphere in space. Your neighbor.
Nobody can, because nobody knows the distance. You know how they discovered the distance of the sun? This is how they discovered the distance of the sun. They said, well, that Venus one day transited the sun, and Venus is about the same size as Earth, and they measured it from East Coast and West Coast, and one of them started earlier and ended later, and they looked at that. They did some really good math. They said, oh, the sun is 93 million miles away. But the question is, how did they know the size of Venus, right? Venus could be the size of a friggin' basketball, right? You don't know.
The sun being 93 million miles away was calculated about 3,000 years ago.
By who? And how did they do it?
It was in Greece when they did the vertical well, and on a given day, the sun was reflected from the water in the bottom on one, and it was on basically triangulation.
Okay. So We'll go back to that again. You're talking about the story of Aristophanes, where he could see the sun at the bottom of a well, so he got his guy to walk 500 miles, and they measured it, and he at the same time could see a shadow. This is a story that was stuck into our history books by the Rockefellers in the mid 1900s. There was many other mathematicians that came out of the same areas of Greece that wrote many books, and none of them ever mentioned Aristophanes and this experiment until the mid 1900s. That's like writing a story about the Chicago Bulls and not mentioning Michael Jordan. All right. This is a made up story. But by the way, it works perfectly on a flat earth. It actually works better on a flat earth, because if we're on a ball earth, we'd all be dead.
I have multiple questions for you, Dave.
Fly. Let's go.
So what were we bombarded with that ended the life cycle of many civilizations here on this planet?
Yeah, that's a great one. So that is a very good one. I wasn't there, but in the app, if you hit the web button right there, and you go to the mud floods, right? And this is not speculation is why it happened, when it happened exactly. But in the mid to late 1800s, there was a worldwide devastation. And I encourage you to hit that list, start watching these videos, subscribe to these channels, especially John Levy and Martin Leakey, and you will understand that all of our history, anything before the 1900s, early 1900s, is off the table. Everything they teach us in school is a lie, and there was an advanced civilization here in the 1800s, way more advanced than we are now, and there's proof of it everywhere in every city, okay? Everywhere. In Connecticut.
I think you're getting wrong on the 1800s. I think you have to go about 18,000 years ago. Yeah.
Well, right? It's there too.
That's your belief. But when you, and here's the thing, we don't have 900 hours. Watch these videos, and then this isn't like, oh, I'm telling you a story. This is showing you what's right in front of our faces. In New York City, there's mud flood buildings here. Our Capitol building was here before Columbus discovered America, that alleged story, right? There's another building underneath our Capitol building, right? There's so much that is a lie, and once you start to see it, then you realize, wow, everything is a lie. And then I think that after this cataclysm happened in the late 1800s, into the 1900s, the people that survived took over the world. These are people that are like, hey, you know what? We're going to keep the secret. We're going to make everyone our serfs. They're going to make us slaves, and they've simply done it.
It goes back further than that, buddy.
It
goes back a lot further.
There's been a reset every 100 years. Every 100 years, there's a reset. Okay, and they do it. They're doing one right now. So if you look. In 1720, we had the plague. Everyone was wearing masks. 1820, cholera. 1920, Spanish flu. Everyone was wearing masks, and everybody died from bacterial pneumonia. Fauci said himself, and 2020, they're doing it again. Okay? This happens all the time. They don't want us coming together. They don't want us putting our energy together. They don't want us knowing where we live. They want us believing that we're on a spinning ball flying through an infinite universe, and we're lost in space, and we have no power, and we're running out of food, and we're running out of dinosaur juice. Another joke. They want us afraid of nuclear bombs and nuclear threats. There are no nuclear threats because nuclear bombs don't exist, right? If you have to take the time to look into these things and see that it's all about control, right? Russia, United States, China, they're all working together. It's all to keep us divided. Divide, and then reset the world. It's not like they have written it in stone, which maybe they have written it in stone. You guys familiar with the Georgia Guidestones?
500 million.
But they've only been around since
40 years, 1981.
Yeah, I was thinking the early 80s.
Yeah, so answer this, right? And I know what your answer is already. Where if you look through the Georgia Guidestones, if you look through one of the center pillars, right here, there's a hole, and you look through that hole, you know what you see, right? Do you guys know?
The sunshine.
Well, no, you see Polaris. right?
Oh, shit.
Polaris is right through that hole. It's been there for over 40 years. Now, in the heliocentric model, they say, in 4,000 years, we're going to have a new North Star. Well, we should have shifted over a half a degree since they built this thing, and a half a degree would be way out of line. But the Polaris is still there. It hasn't moved. We're corkscrewing through space, going 4.4 billion miles a year, right? All the other stars are moving, and Polaris hasn't moved. That tells you that we are perfectly stationary. There's no continental drift, and all of the luminaries are spinning above us. All of the stars are fixed in their spaces, and all of the wandering stars we call planets, and they're named after gods. Go figure that out, right? This is impossible. You guys ever see this one? This is a war veterans thing, and every year on 11/11 at 11:11 a.m., the sun lines up with all of these holes and lights up this little emblem on the ground. One day a year. How is that possible, corkscrewing in a beehive universe? How is it possible that when we have planetary alignments, nothing tugs on anything else, right? Everything lines up perfectly. This is nonsensical garbage we've all been fed.
Everything does tug on everything else. And in fact, since we've had the atomic clocks going, we've noticed that the Earth is actually spinning on its own axis a little faster.
Well, then how come?
Getting shorter.
How come? Like a millionth of a second. Genius, right?
Well, yeah, but it is getting shorter.
Dude, you are believing hypothetical nonsense. How is it that Polaris remains through this hole? How is that possible?
I have to adjust the clocks on the computer systems I work with every now and then for that very drift. No, it's not hypothetical. It's real.
Cheers.
Cheers. Dave, look, bro, we're wrapping things up anyway. Wayne, you got look, we're all grown men here. We're all adults, and belief systems. I'm gonna tell you right now, when it comes to belief systems, everyone has one.
Yeah.
Okay, and they're sometimes they are so concrete. You refuse to even look on the other side of the fence.
Can I go through one more real important one?
Okay. All right, Dave.
On a physical ball.
Let me go to presentation mode, Dave. Hang on one second. There we go.
Right.
Here we go. All right.
On a physical ball. If something goes away, it has to disappear over a physical horizon. So you see my fingernail, that's the boat, and it goes away, and it's behind the horizon. This is a physical horizon right here. If we zoom in on it, you still can't see it because I'm behind a physical horizon. However, the horizon that we have here on Earth is an optical horizon. If the Earth is 24,901 miles around, a 6-foot-tall person standing at the edge of flat water should see a physical water horizon at 3 miles away because there's a 6-foot drop at 3 miles. So the rest of the surface of the water should be dropping off exponentially behind that. But right here in Long Island Sound, I can zoom in on a beach sitting right next to the water, and I can see people on another beach 7 miles away, and there should be tons of curvature. Tons, right? Like a couple dozen feet, right? So what is a horizon? A horizon is where the sky meets the ground, and that's the limit of your view. Now, if you zoom in, you can make it bigger. So here we go. Whoops, that's not what I wanted. Here we go. So we have an empty horizon. So I'm zooming in. So what I'm doing is I'm taking that horizon and I'm kind of making it bigger and bigger. And as I make it bigger and bigger, all of a sudden you can see there's a boat there. Okay? Because I'm zooming in on the boat. And now when I zoom out, it's the same as the boat going away. Watch this boat. It's going to disappear. And it's going to disappear from the bottom up. Right? It's not going over a curve. I just proved it because the boat is stationary. I'm just zooming out. And a glober will go, well, that's over the curve. That's over the curve. And then what it's behind is these tiny little waves in the foreground. My finger cannot hide my face from my chin to my nose, right? But if I move if this was a wave and it was closer to you, look, my finger's up there. Check this out.
But the problem with this, Dave, is because your perspective doesn't change. Can you pause that video right there for a minute?
Yeah. Yep.
Pause that for a minute. All right, now, right there, right? Mm-hmm. If we were to go up on the ledge or go up on the top of a mountain,
yep,
you may just see more of the hull of that boat.
Absolutely.
Okay.
Absolutely.
Now, why is that?
Because I'm showing you. See these little waves here? The water is rising up to your eye level. These waves in the foreground, so if this is a wave, it only covers my chin, but if it was closer to you, it covers half of my face. Can I hide this entire ball behind my finger? No.
But you're not hiding a ball. You're hiding a flat plane.
No, I'm hiding a boat, right? And so, look, this ball, this whole thing can hide behind my finger. Right? It's all perspective. And once you understand how perspective works, you'll start to see that things aren't going over the horizon. A ball requires a horizon at 3 miles. It requires a horizon no farther than 3 miles. So I'm trying to find another.
Then why is it that we're able to visually see? Sometimes you'll see the visibility is 20 miles. The visibility is 14 miles.
Yeah, that has to do with atmospheric conditions. So here's one for you, right? The light, you see things because light is bouncing off of them. Other than the sun is producing its own light. So here's a spot in Illusia, France. Out here is Mount Canigou, but it's 175 miles away. From this height, according to Globe Math, Mount Canigou, the top of it should be over a mile below the physical horizon. You have to believe this is a physical horizon if you're on a globe. Okay? This is an optical horizon. But the Mount Canigou is actually in the foreground. You can't see it because the light that's bouncing off of it can't push through the thickness of the atmosphere, just like you can't see the far end of a long pool, even though the water's clear. It just becomes too thick. But twice a year, when the sun is migrating in between the two tropics, it lines up with this viewing spot and the mountain. And as it goes beyond the mountain, it backlights the mountain, and all of a sudden you can see it. The top of Mount Canigou right here should be a mile below the curve. Okay? The globe scientific explanation for this is the sun has already set, the mountain is miles below the curvature, and it's refracting up and stopping at eye level. Okay? I have to put my glasses back on because that's a cool story. All right? This is right here. This is not a mirage. It's there. You can only see it twice a year when the sun lines up with it. Otherwise, it's invisible. Okay? We can't see forever through the thickness of the atmosphere. As the sun goes away, it just takes its light with it. Light doesn't travel for billions of years. You have to believe that the light coming from Polaris is spreading out in all directions and staying just as bright. That's impossible. Inverse square law of light makes it a quarter of the brightness every time you double the distance. Absolute insanity.
I can tell you.
Well, if you were to get half the distance between here and Polaris, it would seem brighter. It seems the same brightness because that's as bright as.
How about half the distance from here and the moon? It would be 4 times brighter.
The moon isn't a light.
Well, no, any light, a reflected light, its own light. So let's say I'm sitting here, I'm in the middle of nowhere, it's a full moon, and I could read a book by it. Let's just say that's 1 lumen. It's probably more, but 1 lumen. I go halfway to the moon. I go, it's now 4 lumens. I go halfway again, 16, halfway again, 64. And by the time you get to 100 miles from the moon, it's like millions and millions. It's like tens of millions of lumens. It would be brighter than we see the sun here on Earth, but the astronauts are up there taking pictures and stuff. All of it doesn't make sense when you put it to the scientific method. When you actually look at the numbers, look at what they tell us, look at what we're seeing, look at the angular resolution limits of our eyes, look at all of the science, all of it proves that it's all bullshit. All of it's bullshit. You haven't given me one scientific proof other than I saw a fucking light in the sky and think it's a space station, even though it's too small to scientifically see. You haven't given me one scientific proof of the globe. That doesn't mean the Earth is flat.
He actually gets videos showing the solar panels and stuff like that.
You're being tricked. I'm telling you, you're being tricked by an airplane. We had a NASA whistleblower that told us there's 5 of them. 2 are in Alaska. 1 is in Russia. And I forget where the other ones are, and they take turns and they fly. There's times where you can watch it says, all right, you're going to be able to see the space station transit the moon here, and you watch the line, and all of a sudden it just disappears. It's like, what happened? You know, or the lines just stop. They're probably going to get more fuel or something. It should be consistent. It's not, right? It's not. And the thing is, you cannot see. I've said it 10 times already. You cannot see something 50 times farther than a 747 with your naked eye. You can't see it at twice the height. And you guys, that one thing right there blows up your entire world, so you can't accept it.
Oh my God! All right, Dave. Welcome to the Matrix.
Hey,
you're more than
Matt. You're awesome. I told you you'd invite me back. I told you.
You're more than welcome to be back.
I told you you'd invite me back. Matt, listen, I appreciate you. I appreciate your open-mindedness. I don't expect you to believe any of this. But here's the challenge I have for people.
Okay.
I'm offering 3 Bitcoins for 1 proof of the globe. But you have to watch the daily video every day on the app. Every day, a new video shows up. Short ones during the week, longer ones on the weekend. But here, wait, very important. Very, very important. And this is for your 2 guests also and everybody listening. All right. In the app, there's a very important playlist. If you hit the web button right there, right, up comes this playlist, and then down on the bottom right, full-length videos. You hit that list right there, and there's a whole bunch of videos here. These are awesome. Watch them with the family. Get some popcorn. But the top one is a new one. It's called Flatten the Curve. It's whistleblowers from the Navy, from the Air Force, from the Marines, right? These are professionals, and they're explaining how weapon systems work and how submarine sonar work, and it doesn't work on a globe. Just watch that video, okay? Watch that video, and then watch the next one, and then watch the next one, and then you'll be in the same boat as I am, because you'll be like, holy crap, the Earth is flat, okay?
Holy shit, Dave.
Holy shit, the Earth is flat. And one other thing, just to show you that I'm not alone. So this is my area right here. I'm on Long Island Sound. Let it load for a second. This is called the Flat Earth Friend Finder, and these are the number of flat earthers in my area. These are the people that have this app that are on here, and you can message them, you can contact them. I can send out a group message, that smaller circle.
I love
which
the
is
Matrix mind.
307 people. I can say, hey, everybody, we're having a meetup. Excuse me.
Dave
We're having
said
a
he loves the Matrix minds. That's what Dave said.
So there it is. There it is. It's amazing. And if we let's go look at Ohio. I'll just switch to this view real quick. Ohio.
There are a couple of questions about the flat Earth model that I do have. What is the dome made of?
Yeah, the great question. Don't know. I haven't touched it. Haven't been there. Maybe if they let us go to Antarctica, we can figure it out. But some people think that it's ice. Some people think it's frozen oxygen. Some people think biblically it's glass. Some people think it's energetic. Some people think there isn't one. Okay, I don't know. I can't touch it, so I can just speculate on what I think it is. But here's something that which we didn't touch on, and just want to throw it out there. Okay, this one you might like. Okay. The closest planet, the closest star, do you guys know? Closest star? 4.5 light years. Name? Alpha Centauri. Okay? Alpha Centauri, 25 trillion miles away. 25 trillion miles, right? If I was traveling a mile per second for 1 trillion seconds, how many miles have I gone?
Oh, come on, Dave. You got this.
This is easy. 1 mile per second for 1 trillion seconds. How many miles have I gone?
I don't do math like that.
See, this
late at night.
Guys,
at night.
How about this? If I'm traveling 1 mile per second for 10 seconds, how many miles have I gone? 10 miles.
10 miles.
Well, I'm going for 1 trillion seconds. How many miles have I gone?
Well, a trillion miles.
1 trillion miles. See, they don't teach us to think like this. So I'm traveling faster than anyone's ever traveled, a mile per second for 1 trillion seconds. I am now 1/25th of the way to the closest star, where the other stars are magnitudes farther. 1/25th of the way there. How long is 1 trillion seconds? If you guess it within 2 days, I'll give you a Bitcoin.
Well,
I'd have to calculate it.
It's 31,000 years, okay? 1 trillion seconds is 31,000 years. They tell us the closest star is 25 trillion miles away, and we can see it with our naked eye. That's insanity. That's absolute insanity.
But that light...
Except most of that distance, you're not looking through atmosphere.
That star could have been dead
I know that cool story, bro. Right, but the light is the light is still spreading out in all directions. It's getting dimmer and dimmer. It doesn't work that way. Once you understand that light thins, like if I was blowing up a balloon, the balloon's nice and thick rubber. I blow it up, it gets thinner and thinner and thinner and thinner until it's nothing. Okay, until it's nothing.
Who taught you this?
I studied this stuff nonstop for 6-7 years now. So wait.
What is your job? What is your daily job?
I quit my own company, super successful company. I was in a commercial solar power developing company, and we're doing great. We develop commercial solar power systems. We finance them, we construct them, and we move on to the next one. Okay, for commercial buildings. Okay, but I walked away from it all. To be able to talk to people like you guys, to help people wake up, because the world is in chaos right now, and the way they're getting away with it, people are lost in space. They don't know where they don't know where they live. They don't know what power they have. They don't know that they're at the center of creation. They don't know that there's no such thing as nuclear bombs. They don't know that there's unlimited food, unlimited water, that every family in America could have a half an acre in Texas. Okay,
who funds you?
No, well, that's a great question. I sell the app. It's $3. $3 app, and if you want to be able to message people, there's a subscription for $11 for the year. It's super cheap. Just go read the reviews. People love it, and it was able to support myself with the app. So I said, I'm quitting my job. I'm going to do this because I want a future for my kids. I want my kids to have a world where we're not slaves, and we are going into this friggin' slave system right now that people have no idea what's coming in the next couple of years. The World Economic Forum is going to destroy all of us, all right, until we wake up. And what I've noticed is if you wake up to this, you wake up to everything. But let me just finish my last point. So believing that aliens come from if you believe in aliens, of course. Sorry.
I believe in aliens. I believe in ET.
So that they're coming from a planet going around a star. If they're near the closest star, that's 25 trillion miles away. The other ones are way, way farther. But what if the world was set up? What if the world was set up like this? Hold on. That's Antarctica. What if the world was set up like this? We live here. Here is the shoreline of our pond, which is Antarctica, right? And out here, there's more land. What's another word for more? Extra. What's another word for land? Territory. Extra territory. If somebody lived out here and they came to visit us just a few thousand miles, they would be an extraterrestrial from the outer space. Okay? The secret propulsion program is real. It's about getting to outer space here on Earth. There's nothing out there. It's all here. We are at the center of creation. The Earth does not move. It is the basement of what we call the universe, and everything is here. And once you realize that, you unplug from the system. I call the heliocentric system the Matrix. You know, your show's the Matrix, right? Right? I call it the Matrix because you're plugged into a prison system for your mind. And when you unplug from it, you see the reality of this world, and you stop feeding these evil Satan soulless bastards your energy, because that's what they want. They want your energy, and they take it by putting you in fear. They steer your mind with an acronym, the news. The acronym is Northeast, West, South. They're steering your mind. They're stealing your divinity. They're stealing your entire life. And people go, what difference does it make? I still have to go to work. Well, somehow I don't have to go to work. When you take your life back, okay? And by the way, this is much harder than my job. My job was so easy, okay? This is so much harder. But I couldn't be happier because I'm doing something that people love. Go read in the App Store. Go read the reviews. The reviews on my app are the highest rated app in the App Store. Everyone loves it. It's $3. A homeless person can afford it. And by the way, if you can't afford it, like you're on your parents' bill or something and they can't get an app, email me. I'll give it to you for free. Okay?
You're going to give it to me for free.
I will absolutely give it to you for free. You have an Android or an iPhone?
I got a Droid.
You got a Droid. Perfect. I will email you a free download and you'll be good to go.
I want to review this app.
Here's the thing. Here's the thing. You can't find the information yourself. This just feeds you the information. All right. And just watch the daily video every day. It's going to remind you. It's like, hey, new videos up. He's like, oh, let me see what Dave put up today. And people kind of like the videos I pick. I actually work hard at picking good videos and just start watching them. And right next to the thumbnail is a little button that says archive. You can go hit that, and it got all the months from all the years previous. And so it's an endless amount of information. Check out the mud floods. There's so many buttons on there. You can cancel your cable, and you can send me half of that bill, right? Because I'm just saving you a ton of money. All right, I'm kidding about that.
I got one more last question for you, Dave, and that's this. You ready?
Yes.
If this was so detrimental to the powers that be,
why didn't they come and get me?
Why don't they lock your ass up?
Because I believe that we have free will, and I believe that there are rules that they have to play by here, maritime law, and that they play in this realm where they know that they can't break free will. They can't kill people. They just convince other order followers to kill other order followers. If I convince you to go kill your two friends, that's on you, not on me. Okay, and so that George Bush didn't kill anybody. He just convinced people to go kill other people. Okay, so. They want they can't, if you, and a lot of this, listen, I was a full-on atheist before I understood that we're at the center of creation, therefore there's a creator. And the journey that you take from there, once you realize there's a creator, that's your own personal journey. I don't even want to know about it. All right? So once you understand what this is, you take your power back. Life has never been better. Every single one of those blue dots on that screen, every single one of those blue dots on the app, they're awake, aware, smart people, right? They're awake to all the nonsense, right? So again, check it out, and you can find me at flatearthdave.com. All the links to my interviews, my video channels, my DITRH channel. DITRH is right there, that guy right there. I have short videos. Most of my videos there are under 3 minutes, 4 minutes, okay? And so just watch that stuff, educate yourself, and see what happens to your life. It only gets better.
It definitely sounds like it gets more interesting.
It does. And I ask every flat earther out there, I discovered flat earth 6 months ago, 2 years ago, 5 years ago, and I say, have you had 1 second of boredom at any point in the since you discovered? They're like, absolutely not. No. There is no boredom whatsoever, because this world is amazing, and almost none of us have cable television. We got rid of it all. Okay?
Right.
Now, yeah, some of us, occasionally I keep threatening my girlfriend, let's watch a movie. Let's watch a movie, right? Because sometimes you got to escape from this. And then the movie that I'm going to try to watch for the last couple of days is Wag the Dog. Right? Wag the Dog. Because it's basically it's a documentary of what's going on right now. So I highly recommend.
I was going to say that's the wrong choice for an escape.
Well, you know what? That I escape by analyzing the shit that they're programming us with. So it's a lot of fun.
You know what? I got to have you back, Dave, and because I can tell you right now, you are a truther. All right, I know you are.
You want to see truth? Go to stoplookthink.com. Stop. I'm not going to tell you who owns that.
I got to have you talk sometime with me and all of the other brainiacs about the New World Order and Project Looking Glass. Project Looking Glass, the technology, all of the different topics that we cover, because they, like I told you in the beginning, I have got an open mind, okay? Not open enough to my brain's gonna fall out, but enough to question the reality that I'm in, okay? And indeed, I'm going to question a lot of the things that you shared with me tonight. If you give me the app, I will watch the videos when I got time.
Yes.
Follow me? I mean, I'm serious, Dave. Whenever you said, I think you're gonna like me, Matt. Dave, I do like you. Okay? I do like you. You're a little pushy.
I am a little bit. Well, that comes with my heritage, I guess.
Yeah.
I'd love to get Matt. I'd love to get him and Charlene at it.
Charlene's from Jersey there, so I got hands on $5 on the girl, dude.
I actually had access to Project Looking Glass, and I'm going to show you what I saw. What I saw.
Shit. Don't do this.
What I saw.
Dave. Don't do this.
This is what I saw right here. It shows that in January of 2021, there's going to be millions of people on the app. And Neil deGrasse Tyson is on the run. Bill Nye and his bow tie are in jail. Right? It's Project Looking Glass. I saw the newspaper. There you go.
Jesus Christ. All right. Well, you know what? You got to at least plug the Matrix on your show because I know you have had.
I don't even have a show. I go on other people's shows,
Well,
but
you're
I
gonna.
will. No. You will be your video. And I'm recording it. So I'm gonna put this on YouTube, and it will be on the app. Right here. So if I go back to the homepage and I hit the web button, and right here is my interviews. I'll click that, and you'll be right at the top of that tomorrow. Okay. And by the way, there are a few interviews in here. I probably don't have 20 minutes to get to the bottom of this list. It goes on and on and on.
See, that's how you were able to float them numbers as fast as you were. Boom, 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 boom. But it's okay. Look.
All right.
Again, nobody comes here. Nobody comes to Matrix without saying something positive. So, Mr. Wayne Stewart, you are the guest caller. Dave's interview. Say something positive to humanity, Mr. Wayne Stewart, on your way out the door, will you please?
Well, I am positive that most, if not all, of what we are fed daily is indeed inaccurate, incorrect, and outright lies. And we are in the process of breaking the matrix and getting down to what's real behind the lies. And I think we're going to make it.
I agree. I think that we are going to win, and as soon as people get their heads out of their rear ends and realize where we are, that's going to make the difference.
Hell yeah. All right, Mr. Wayne Stewart. Thank you, buddy. I appreciate you, Wayne, like always. And Mr. David Weiss, Mr. Flat Earth Dave. Say something positive on your way out. Again, I thank you. I appreciate you for sharing your vast amount of knowledge on where we possibly could be.
Guys, all I say is don't believe anything I say. Go verify it yourself. The best way is with the app. But if you don't have a smartphone where you can have the app, you need an Android 8.0 or higher, and an iPhone 6 or better. Just go to flatearthdave.com. There's plenty of resources there, all for free. My podcast is there, endless videos. It's all you really need. It's all there.
Awesome.
Flatearthdave.com.
Flat Earth. See, that's the thing. I didn't put it down below, or I would have. Dave, again,
That's all right.
I appreciate you one more time, my friend. And yeah, you have made a friend in Ohio. Okay, we've got lots of things to talk about because this is only one topic that you and I both like dive into. I can tell you that right now. This is only one topic that you and I can connect on. Okay, because I don't know where the hell we're at. Okay, so any kind of vast knowledge would be much credible. All right, good night to you, Mr. Dave. I appreciate you without a doubt. Thank you once again.
All right, man. Thanks so much.
All right, good night to you.
We'll see you.
All right.
Recording stopped.
All right, my friends. Mr. Dave be out of here. Mr. Wayne Stewart still left in the house here. I'm going to go ahead and close out Wayne. So Mr. Zoom call would be gone. Wayne, I don't mean to do this to you, but I'm going to do this to you. I love you. I'll see you. To everybody, shout out to everybody one more time here in the Matrix Minds. You guys just heard it. I'm glad that we did not argue. I'm glad that we did not fight. Because, again, I'm a person that questions every single thing that I'm around. I truly do. And he had some really, really, really good, valid points. Won't lie. But that right there that I'm looking at, welcome to Earth. You got Mercury, Venus, flat Earth, all right? Mars, Neptune, Jupiter. You know what? Oh man, it's a little bit too much for the head to wrap around. Again, you got to dig into it. And you know what? It's not that I'm just gonna brush it off. I mean, I've been searching for the inevitable, possible, probable for a very long time. And the only thing I can say is I've heard Larry Hawkins say this. Let me share this. And I gotta share this because there are those who know, without a doubt, where we are, what we are, why we are. I'm talking to the ABCs, talking to you, from Homeland Security to the Department of Defense to every single one of you. CI tells a lie. All of you. From the top to the bottom and from the bottom to the top. You guys, somebody knows what's going on right there. Somebody knows what's going on. And you just heard an interview from Flat Earth Day, okay, Dave Weiss, who is obviously gaining some momentum here in this Flat Earth movement. Once again, I'm coming back, right? The mud flood, I've heard about Tartaria, I've heard about all that stuff. But I'm a matrix mind. And the majority of the brainiacs that are around and listening are also matrix breaking minds. We question every single thing. Every single thing that we're fed. Every single thing that we're shown. Every single thing that we're told. We believe none. We believe none of what we hear and only one half of what we see. So I loved having Dave here. But on behalf of my own self and my own spirit, I'm going to believe none of what I heard, and I'm going to do some damn digging. Okay? I'm going to do some digging. And again, ABCs, you guys swore an oath. You guys took an oath to the people to protect us from all enemies, both foreign and domestic. And I'm going to tell you now, if there is somebody on the outskirts of wherever the hell we're at, whatever we're doing, for whatever reason, it is your job. That's right. Why don't you? Now the ball's in your court. The ball is now in your court. My friends, it has been an absolutely amazing, awesome evening. And once again, I appreciate you for joining myself and Flat Earth Dave that presented to us the Flat Earth, his Flat Earth model. You can either believe it, you can research it on your own. But somewhere, the truth is out there. I don't truly believe his model, and I definitely don't really truly believe my model. I have no fucking clue where we are at, Brainiacs. All I can do is tell you what I experienced on my own. And I'll not lie to you. I will not lie to you. If I tell you that I've experienced something, I'm going to tell you the truth. Validity. I'll give you validation. Okay? So with that being said, my friends, I will catch you, all of you, both on the video side of things as well as the audio-only side of things on Monday night going into early Tuesday morning here on the Matrix Minds. You guys, please be safe. Take care of each other as well as take care of yourself. And I'll see you here on Monday at 10 o'clock Eastern Standard Time, 9 o'clock Central Time, and 7 o'clock Pacific. Good night, everybody. Be safe and question everything, even reality, my friends. Good night.